Here in this problem that was in the final exam, a cyclist must travel 800 kilometers. How many days will the trip take if the cyclist travel 10 hours a day at an average speed of 16 kilometers per hour? So the information here is that there is a cyclist. He's moving between A and B during his trip. The distance is 800 kilometers. His average speed, V average, is 16 kilometers per hour. So here we have the distance and we know the average speed, so we can find the time required for this trip. We know that V average equals to the total distance over total time. If we substitute here, eight 100 kilometers divided by the 16 kilometers per hour, we can use our calculator. That's 50 hours. So the time required for this trip will be 50 hours. But he says here he rides his bicycle 10 hours only every day. So every day, like every one day, he rides for 10 hours. So what if we have the total trip to be 50 hours? How many days do we need? We can make it any symbol like Z. So if one day is corresponding to 10 hours, so Z is corresponding to the 50 hours, we can use this mathematical method to find Z. Z will equal to 1 times 50 divided by 10. That gives us 5 days. So the right answer for this question will be 5 days. Second question, and this one was in the measure 1. He mentions here, which of the following graphs represents a motion with constant non-zero speed? Constant non-zero speed. If you look here on the first graph, it's a position versus time. The second one is also a position versus time. Third one is a speed versus time. Fourth one is speed versus time. Let's analyze the first one. The first one, the position increases linearly over the time. That means the speed here is constant. That means a constant speed. The second one, the position is constant over the time. That means a stationary object, or the object is stopped, does not move. The third one, it's a speed, not a position. Speed versus time, and the speed increases with time. So that's not a constant speed, but it's a constant acceleration. Constant positive acceleration. The last one is also a speed versus time, and the speed decreases gradually or linearly. That means a constant negative, not speed, it's a constant negative acceleration. Here he's asking about what? Constant speed. So constant speed, this is the only case of constant speed, so I will choose number A. This question The figure below represents the position of an object as a function of time. What is the displacement of the object? So he's asking about the displacement of the object after 5 seconds. So this is a position versus time graph. And if you look here, the object starts at position 2, then it moved to position 1. For 1 second, it stopped, and then it moved to position 3. That's position 3 here. And then it stayed at the same position for 1 second, then it moved to position 2. Here he's asking about the displacement during 5 seconds. Displacement equals to final position minus initial position. So if we are moving on the x-axis, we can call it the position final minus the initial position, or xf minus xi. Final position minus initial position. Where is the final position here? This is the final point at 5 seconds. And if you look here to find the corresponding position, it's 2. So x final is at 2 meters. Minus the initial position, and the initial position here is at the same point, which is 2. So 2 minus 2 is 0. That means 0 displacement, which is the first choice. What about the distance? If he asks you about the distance, what's the distance during the first 5 seconds? To find the distance, you need to accumulate all the movements here. Like starting during the first 1 second. Here in this part, the object moves from the position 2 into position 0. That means it's 2 meters. Then it stopped. So that's 0 meter. Plus it's moved again from 0 meter up to 3 meters. That's 3 meters. Plus it stopped again during the fourth part. That's 0. Plus it moved from 3 into 2, that's 1 meter. And if you accumulate and sum all together, that's 6 meters. So this is the distance. Okay, so the total distance here will be 6. What if he is asking you about the displacement during, let's say, the first 3 seconds? The first 3 seconds. The displacement, as we mentioned, it's final position minus initial position. So the displacement during the first 3 seconds, from 0 to 3 seconds, x final at the 3 second, it's in this position, so that's position 3. So this is the final position. Minus the initial position is here, so it's 2. 3 minus 2 gives you 1. So this is the displacement during the first 3 seconds, and so on. Here in this problem, it was in measure 1. The position time graph. So this is a position time graph of an object's motion is represented as in the figure below. What is the average speed? So he's asking about the average speed of the object during the 100-second motion. So the 100 second is this period from 0 to 100. So now what is the average speed? Average speed is the total, distance over total time. So we need to find the total distance here. To find the total distance, you need to accumulate all the distances over all the periods. What are the total distance? From 0 to 20, the object moves from 0 up to this position 20. So that's 20 meter. Plus, from 20 to 40, the object stopped. So that's 0 distance. Plus, from 40 to 60 seconds, the object moved from the position 20 here into the position 10. So it moved 10 meters. Then, from 60 seconds to 80 seconds, it stopped. That means 0 meters. Plus, from 80 to 100, it moved from the position 10 into the position 0. That means 10 meters. If you accumulate all of them together, that's 40 meters. This is the total distance. So the total distance will be 40 divided by the total time, which is 100. That gives you 0.4 meter per second. So we will choose the first one, 0.4 meter per second. What if he's asking you about the average velocity? Average velocity. Let's say he wants to find the average velocity during the first 100 seconds. The first 100 seconds. Average velocity is displacement over time. What's the displacement? I started from this point at 0 and ended at this point at 100. So the displacement here will be the final position, which is 0, minus the initial position, which is also 0. So it's 0 minus 0 gives you 0 over the time, which is 100. It gives you 0 meter per second. So the average velocity in this case is 0 meter per second. Let's look at a different question. Which of the following is always true? Always true. About the magnitude of the displacement. The magnitude of the displacement. It's less than or equal to the distance traveled. So he's comparing between the displacement and distance. Let's remember, if I want to move between 2 points, A and B, what is the displacement? The displacement is the shortest path between both of them. So this is the displacement. Displacement. So regardless the real path or the real track, this black line represents the displacement between A and B. But what about the distance? You can move from A to B directly on this red line. So in this case, the displacement and the distance will be the same. They will equal to each other. Or you can move from A to B in different paths, like this one. And in this case, the distance will be greater than the displacement. Or you can move whatever, any track. And in these other cases, the distance will be greater than the displacement. So we have two cases here. The distance might be equal to the displacement, like in this case, or the distance might be greater than the displacement, like the other two cases. So here in the choices, he says the displacement is less than or equal to the distance traveled. That's right. It might be less than the distance, or it might be equal to the distance. So this one is right. What about the other choices here? The displacement is greater than the distance. That cannot be happened, because in all these cases, displacement is either equal to the distance or less than the distance, but it cannot be greater than the distance. It's equal to the distance traveled. This one is partially right, but he says here it's always true, always true. So you cannot choose this one. The third one, or the fourth one, number D, it's less than the distance traveled. And this one also is partially right. But you cannot choose it because he says always true. The last one, none of the statements are always true, and we cannot use this one also. So the right one will be the first one, that the displacement is less than sometimes or equal to sometimes to the distance traveled. In this question, a person drives 200 kilometers to his grandfather's house. On the way to the grandfather's, he drives half the time at 50 kilometers per hour and the other half of the time at 100 kilometers per hour. So we can divide this trip into two equal times, not two equal distances, but two equal times. This is the first part and this is the second part, from A to B and from B to C. From A to B, the time consumed, I will call it T. And from B to C, this is the second part of the time, and also it's the same because he says half the time and half the time. During the first one, the speed is 50 kilometers per hour. During the second part, the speed is 100 kilometers per hour. The total distance traveled from A to C, the total distance is 200 kilometers. So he's asking now about what? What is the total time of the trip? What's the total time for this trip? Half the trip is T and the other half is T. So the total time will be 2 times T or T plus T, whatever you say it. So we need now to find the time for each part, from A to B and also from B to C. He's driving with a constant speed. So I know that the speed here is the distance over the time, or I can rewrite it in this way. The distance equals to the speed times the time. So this is the equation that I'm going to use. From A to B, the distance from A to B equals to the speed from A to B, which is 50 kilometers per hour, times the time T. And the distance from the point B to point C equals to the speed in the second part, which is 100 kilometers per hour, times the same time, because both times are the same. The first distance plus the second distance must equal to the total distance, which is 200 kilometers. The 200 kilometers is the total distance. So let's substitute the first one, which is DAB, equals to 50 times T, plus the second one will be 100 times T, equals to 200 kilometers. So if we can solve this equation, we can find the time T. We can add both together. 50 plus 100 gives you 150 times T equals to 200. So we can find the time T. We can calculate it. 200 divided by the 150 gives you 1.33 hours. So this is the time for the first part and also the time for the second part. So the total time will be 2 times T, which is 2 times 1.33 hours, gives you 2.66 hours. But the choices here are all in minutes. So you need to multiply your result, 2.66 times 60, to convert from hours into minutes. 2.66 times 60 gives you 160 minutes. So we will go to the choices here and see, yes, 160 is the first choice. I hope you enjoyed these 6 problems, and inshallah I will record some other problems for you to practice on the describing motion or the velocity and momentum, and also on the acceleration inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.